Hello, dear students. Welcome to this new lesson where we are going to see how to write algorithms. As you can see, this is the exercise that was given to you in the previous lesson. I hope you guys succeeded. And in case you could not, just drop a comment to this video and join our channel, be it WhatsApp or Telegram, for the solution to be properly explained to you. Okay, let's dive into what we are to do in this lesson. Okay, writing algorithms. In order to write algorithms, it is crucial, that is very important, to know the vocabulary associated to algorithms. That is variable, constant, data type, operator, assignment. Because for you to be able to master or better understand a particular concept, you should be used to its vocabulary. Okay, and the words used to better understand algorithms, we have variable, we have constants, data types, operator, assignment. Now, the first one, variable. A variable is a container for a value that may vary during the execution of a program. Variable names must have a meaning in context to the algorithm. So that is what we define as a variable, a container for a value. That is, it is the container, it is what contains a value, and it may vary during the execution. That is, the value it has can change during execution of the program. And the variable name must have a meaning, very important, because remember that when you are writing algorithm, it is very important for other programmers to be able to read your algorithms, and in such a way it is better or excellent for variable names to have meaning. For example, if you are writing an algorithm to calculate the area of a rectangle, it will be excellent to have as variable names length, width, for everybody to understand the purpose of such variables than to be using something like John and Mary. Although it is correct, but it is not a good way of designing the name of algorithms. A good variable must start with an alphabetical character or a special character. And when we mention special character, we are talking about the underscore only. So if you want your variable name to start with a special character, that special character should be the underscore. Okay. Next, yes, a special character we are talking about is the underscore, because a simple dash cannot be used. A forward dash or a backward dash cannot go as well. So the only special character we can use in a variable name is the underscore. Next, a good variable can contain a number, but only either in the middle or at the end of the variable name. So I can have number one, I can have number two, but I cannot say one number. No. If you must use a number as part of your variable name, then that number should be either in the middle or at the end, because we might go across algorithms whereby we can need three different variables of the same type, and in such a way we can list them with the same name but using numbers to differentiate them. Okay, good variable names, we have number one. As you can see, the number is at the end. Length, total score, total score. Okay guys, this is a trend many programmers are using now. When you want to use a variable name that has more than a single word, it is either you use an underscore, as I did here, to link the two words of the variable, or when you want to start the following word, you use a capital letter, as you can see. So if I want to say total surface area, I will have total with capital T, I will have surface with capital S, and area with capital A. Or I can simply have total underscore surface, total underscore area. Okay, we have area 2, we have L. Sorry, this is not 1, this is L and V. Those are good variable names. Bad variable names. Day 1, we realize that this is considered as an operator. We are going to come to it. This is considered as an operator. I hope you guys can see the difference between a minus sign and an underscore. That's the difference. 8 go cannot go because the number is at the beginning. Area 2, due to the fact that there is a space, in case it is a program, the compiler will understand that area is a variable and will consider 2 to be as a variable, and since it cannot be the case, you are going to have an error. UML Yes, this is a good variable name. Sorry, this is a good variable name. And this one is not a good variable name because of the hashtag. If I take the case of C programming language, the hashtag is used, for example, when you want to import a particular library. Total.score cannot go because of the dot. Remember that the only special character you can have is the underscore. The next one, a constant. Constants are identifiers whose values do not change, e.g. pi. We know that pi from primary school, secondary school, university, pi will remain 22/7 or 3.14. We will define a constant using the keyword const. Very important, guys. When writing algorithms, if there's a constant we'll be using, we are going to use the keyword const to define that constant. I hope now you are seeing the difference between a variable and a constant. A variable, the value may change during execution, but for a constant, the value do not change. Next, the data types. Data type determines the set of values that a data item can take and the operations that can be performed on the item. Remember, you are going to have a special chapter on this particular one, data type and data structures, where we shall be digging and entering byte by byte in all the different concepts related to the chapter. But for now, it is very important for you guys to only know the basic data type that we might be using when writing our algorithms. We have integer, whole numbers, both positive and negative, like -1, 6, 70, -452. Real or float. These are positive and negative numbers with decimal points, -1.3, 6.85. We call them real numbers or float. Boolean. This is a data type having the logical values true and false only, and it is the only data type having two possible values. We call it Boolean. So when writing your algorithm, if there is a variable that can accept only two values, then you can use a Boolean for that. Other programmers use integer and they assign 1 to true and 0 to false, just like in logic gate, which is still acceptable and very correct. The next one, char. These are single alphanumerical characters, e.g. C, 2. Remember that 2 with this quote is different from 2 without a quote. 2 without a quote is an integer and addition, subtraction can be performed. But 2 with the quote is a character on which addition, mathematical operation cannot be performed. Those are the four basic data types that we are going to go across. Operator. This is a symbol that specifies the mathematical, logical, or relational operation to be performed. Remember that when we have operators, it is very important to know on which data type they can be applied. Some of these operators are, we have the addition, as you can see, 5 plus 4, 9. We have subtraction, 5 minus 4, 1. We have multiplication, 5 times 4, 20. We have division, 5 divided by 4, 1.25. But guys, if 5 divided by 4 is assigned to an integer, as I told you during dry running, then only 1 will be assigned to the integer, because if you are try and assign a real or a float value to an integer variable, that integer will only store the integer part of the float. Next, we have the mode. Very, very important. This is a variable that is, I will say, underrated, like some football players. This is a variable that is very important, but many do not know about it. The modulo division, 5 mod 4 is equals to 1. Why? This operator returns the remainder after division is performed. At this level, I am returning the final value. 5 divided by 4 is 1.25. But when you go detailing in the division, you realize 5 divided by 4 is 1 remainder 1. That is why 5 mod 4 is 1. If I take another example, 5 mod 3. When you take 5 divided by 3, what do you get? 1 remainder 2. Therefore, 5 mod 3 is 2. These are the different mathematical operators we have. As logical operator, we have less than, we have less than or equals to, we have greater than, we have greater than or equals to, we have equals to. Yes, equals to is a logical operator. Take note. We have not equals to, which can either be represented like this or like this. So do not see this symbol and say you do not know the meaning. Not equals to can be presented like this or like this. Very important. Mathematical operators return integers or real numbers as result. That is, if you use any of these, your answer will either be an integer or real number. But modulo returns only integers, while relational operators return Boolean values as result. Also, relational operators are only used in condition. Let me explain myself. If I take, for example, 5 less than 4, there is no, if I take 5 minus 4, my result is 1. But if I say 5 less than 4, what do I have as answer? It is either it is true or it is false. That is why we say relational operators return Boolean values. The next one, the assignment operator, the arrow. In algorithm, we mostly use arrow. I always say it, using equals to as an assignment operator is a bad practice because it can confuse a student when you are going to use this sign in either the while statement or the if statement. So, dear students, it will be better to use this symbol, the arrow, as your assignment operator. Okay, let's proceed. Steps in writing algorithms. 1. Understand the problem very well because you can't solve a problem that you don't know. Very, very important. If you are being asked to write a program to calculate the area of a square, if you don't know how to calculate it on a piece of paper, then it will be impossible for you to write the algorithm. That is something you have to understand. When an algorithm is given to you, the first thing is to understand the problem. If you don't understand the problem, then you can never write the algorithm. 2. Identify the variables needed, the input, the output, and the processing variables. Next, plan the logic of the problem by breaking it into steps. Next, structure the code by using indentation to show hierarchy. When we talk of indentation, it is a practice that should be common with you students in order for you to easily trace errors. When we shall be doing programming, you are going to better understand this thing of indentation. I think the last one, test the algorithm and fix it if it doesn't solve the problem it is supposed to. Okay, guys, as we saw as the disadvantages of pseudocode, which is that different programmers could not easily communicate on a particular pseudocode. It is because there is no specific standard for writing pseudocode. But according to me, the best is the one given below. That is, you have the keyword algorithm, you give the algorithm name, you begin, you declare your variables, that is, declare variables and constants. For example, if I have the variable area, which is a real, I will say area colon real. I give my program logic and I end. Personally, this is the best standard for writing pseudocode. Let us proceed. Sequential control algorithms. Question 1 says, write the algorithm for finding the sum of any two integers. So you are writing an algorithm to find the sum of any two integers. And we know that for me to get the sum of two integers, I must have those two integers first of all. Then I simply add them using the symbol for plus and I return my output. Okay, let's proceed. First thing, algorithm sum. So you see that the name of my algorithm is sum. The next one, I begin my variables number 1, number 2, and the sum. We have our three variables. Next, print, enter any two integer. That is, we want the person executing or dry running the algorithm to know that he has to enter two integers. From there, we read those two integers that the user will enter, and the first integer he will enter will be assigned to num1 and the second will be assigned to num2. Remember that read is a keyword for input and print is a keyword for output. The keyword we saw under pseudocode. In case you did not follow the video, I will recommend you to go and watch for you to be used to the different keywords that have meaning under pseudocode. Now, after we have num1 and num2, we simply have what? Sum takes, that is, it is initialized to the addition of num1 and num2. For example, if num1 is 2 and this is 3, then when you add this, you have 5. So sum is now 5. After having the sum now, what should I do? I simply print the sum is. Now, let me explain this particular one. When you see this in quote, it means it is a text that is going to be outputted. The sum is, and now I have this comma. You separate the text from the variable, and now this, as it is, when you have a variable inside print, it is not the variable name that will be printed, but instead the value. So if sum is 5, this will print the sum is. Instead of printing sum, it will print 5. And take note, many errors that student go across is thinking that this sum is this sum, because you will be given another program where they will say output, for example, let me say that you should output the volume, or the output is something very long. You can just use a particular letter um to represent the output. And here you can use the full name now, so that when it will be outputted, they will clearly see the volume is, and here you simply have V. Many students think that this and this are the same, whereas it is not the case. That is why I use this to be in red, for you to know that this is actually the variable that was declared, and this is a normal text. After that is done, that is the end of the algorithm. And you can see the indentation. You see that all this block is under begin and end. For now, you might think that it is not really important, but when we are going to dive in into algorithm that makes use of more than a single control structure, that's when you will see the importance of the indentation. Algorithm 2, write algorithm that swaps the value of two variables. Now, what does it mean to swap? Swapping simply means if I have at the beginning A is 4 and B is 6, then at the end A should be 6 and B should be 4. That is the swapping that has been done. So I have two variables at the beginning of an algorithm. After the algorithm has completed its execution, the two variables have the value of each other. Now, how can this be done? Let us break it down to understand how it can be done. It is just like you have a particular ball, your friend has a ball, and you guys need to exchange, and you have a single hand. The ball should not fall. How will you do? I asked that to one of my students. He said, we are going to throw our balls up, and he picks mine, I pick his own. Such a funny way of reasoning. But he was right, it can be performed. But now, in the context of algorithm, how do we proceed? First of all, we can use a third variable to do the exchange. That is, you have both your balls, and now you want to exchange. A third person can come in to help you guys facilitate the exchange. Let us see how it goes. A is 4, B is 6. I use my third variable T. How do I proceed? First of all, T takes 4, as you can see. Then A takes the value of 6. And finally, B takes what was with T. And that is how I have performed the swap. I hope you guys saw how the logic is. That is, the value that was here is given here. The value that was here is given up, and finally this one takes the value that was here, and that is how the swap is done. Let us proceed. So as variable, I have A and B, the two integers. I have to swap their values, and I have T, my intermediary integer. As you can see, let's proceed. Print, enter any two integers. We enter the two integers. Sorry, here is supposed to be A and B, because I just did a copy and paste and I did not edit. Sorry. Here is supposed to be A and B, A and B. That's what we are reading. Now, print the values of A and B before swapping are A comma B. So yeah, I'm going, if A is 2 is 6, if A is 4 and B is 6, as you are seeing, this will print the values of A and B before swapping are 4 and 6. Remember that this is not in the quote, so it is their value that are going to be printed. If they were inside the quote like these two, then it is A and B that will print. So at this level, I will print A and B, but here it is the value of A and the value of B. That's why they are not in the quote. And if there is no comma, then we are going to see that AB is one variable. That's why we use a comma to separate those variables. Okay, we proceed. T takes A, as you can see. A takes the value of B, and finally B takes the value of T. And that is how we have swapped the two numbers. Print values of A and B after swapping are A, comma B. So this is the logic that is behind the swapping, as you saw in the sketch that was being done here. And that is the end of the swapping. But now that was just approach number one. You can have a simpler approach to swap two numbers without using a third variable, because I remember I saw a regional mock paper where a student were being asked to write a subroutine that perform the swapping of two integers without the use of a third variable. Good. If we are not using another variable to perform the swapping, then it reduces memory in one way or the other. Let us understand. We can use sum and differences to swap the numbers. How? That's a question you should be asking yourself. Let me show you guys. A is 4, B is 6. What should I do? A takes the value of A and B, the sum of A and B, as you can see. So A is going to be 10, because when you add this, you have 10 together. Are we there? Perfect. We proceed. Now, B takes now A minus B. Remember, A is now 10 and B is 6. So B becomes 10 minus 6, which is 4. And we end by saying A takes now A minus B. What is A? A is 10 and B has value 4, because from the previous operation we saw that B was 4, and when you subtract you have 6. So you see that at the beginning A is 4, B is 6, but at the end B becomes 4 and A becomes 6. This is the approach we use to swap two numbers without the use of a third variable. So we have our algorithm, the same error, it's a copy paste. Once we have A and B, what do we do now? A takes A plus B, this is the operation. B takes A minus B, this is the operation. And A takes A minus B, as you can see. So these three different steps perform the swap. And you ask yourself, is it possible to have these three computations on the same line? Yes, since they are separated by a semicolon, it is possible. But I did so because of problem of space for me to be writing the algorithm while you see the logic under. Now, we print the values of A and B after swapping, and we end our program. That is just what we are having for example 2. So that was the second approach in swapping two numbers. In our next class, we are going to see selection control algorithms. That is how to make use of if else, and switch statement. I hope you enjoyed the video and you have a good and excellent perspective on how to properly write an algorithms with the steps that were given to you. Do not forget to like, to subscribe, and to share for our community to grow. Thank you very much.